Here we've been given the axis of symmetry is -3. We know that that has to do with the vertex, but we don't have the y-coordinate of the vertex, and we've been given 2 random points. So I'm just going to try to sketch this graph. Okay, so I have x equals -3, maybe about here. That's going to be my axis of symmetry. And at 2/6 up, somewhere around there, 7/6 up, or 7/21, maybe somewhere around, let's say right about here. Okay, so at this point we don't really know, it's hard to tell if this is upside down or right. So I haven't really graphed this very accurately either. I suspect maybe, we could maybe hypothesize that the graph looks something like that. Okay, it's really hard to tell though. Okay, because it looks like this point is maybe a little bit closer. So this graph is going to be upside down like that. Okay, we're not too sure. So we're just kind of hypothesizing. So how do we set this up algebraically? Okay, so again, the physical characteristics should give us some indication of the algebra involved. So I'm going to try to use graphing form when I can. Okay, so I'm going to go y equals, I don't know a, I do know that the p value though, so I'm going to go +3, make sure you use a squared, plus q. So at this point, that's all I know so far, and I have 2 unknown values. But I do know that I can plug these coordinates into x and y. But the problem is if I plug one in, I still have 2 unknowns. But if I have 2 unknowns, you should think right away, I need 2 equations to solve this as a system. So I'm going to set up my 2 equations by plugging in my 2 coordinates. So one equation is going to be generated by substituting in 2 and 6. My second equation is going to be generated by plugging in the 7 and 21. This is not +5, it's +3. +3 squared plus q. So when I solve for this, I'm going to end up with 25a plus q. Here equation 2 is going to be 100a plus q. The nice thing is I have my 2 variables, I have my 2 equations, and the q's match up. So I'm just going to take equation 1 and subtract it from equation 2. So I'm going to take my equation 1 here and go subtract that from equation 2, and that's going to give me 15 is equal to 75a. The q's cancel out. I am able to solve for a. A is equal to 1/5. Is that positive 1/5 or negative 1/5? So 21. So it looks like it's positive 1/5, if I'm not mistaken. 21 minus 6. Yep, that's going to be positive 1/5. So it looks like my graph is going to be more like that. I don't know. I'm not too sure I can graph this, but okay, something like that. Kind of hard to draw. I don't think I drew this original point very well. Okay, so that's going to be my a value. I need to then solve for q by plugging back in. So I'm going to just plug it back into equation 1 and say that the a value, so that's 25a, my a value was 1/5. Solve for q, looks like q is equal to 1. Okay, so when I sketch in this graph now, I know where my vertex is. It's going to look something like that and something like that. Okay, so there's my parabola. I've got solved for all the parts. I now just need to write my equation. A is equal to 1/5. P is equal to -3 and Q is equal to 1. So there's my equation of my parabola. So how did I do this again? Well, I used setup. I've given the axis symmetry, so I decided to use the graphing form. Now the graphing form isn't always going to be the best choice, okay, but it's the one that we would like to use if possible. If this would work actually if we tried using some other one of the other forms, but again, this kind of leans towards the graphing form. Once I decided on that, I plugged in my known parts. I have two unknowns. I had to set up two equations to have a system of equations. I did that by using these two coordinates, and I solved this as a system of equations.